I need to quickly state before I get into this that the title says kinda because this isn't an exact copy of TangoTek's factory. Whilst trying to go through some of his videos and streams, I tried to make sense of some of the redstone used, but I just couldn't. So I recreated the same machine as close as I could in a way that I could still understand, and also explain it in detail to you guys. This machine is slightly slower than the original, and looks different, but it's functionally the same. That being said, if anyone is able to explain some of the wizardry that Tango used in the original, or can give suggestions to make this setup even better, then feel free to comment about it. I've broken down this machine into 9 parts, each with their own colour, and I've separated them into different chapters you can skip forward to if there's something specific you want to see. I'm going to try and explain everything in quite a lot of detail, assuming you know nothing about redstone, and that you just want to build a cool crafter setup. So if you already know some of the basics of redstone, then some of this might not be important to you. We'll start off with this hopper clock here, which is where everything starts, the factory. Once this lever is turned off, the factory would start. That's because these 2 blocks of redstone are powering these blocks, which both lock these hoppers. Between these 2 hoppers, there's 25 items. Because hoppers transfer items at a rate of 2.5 items a second, it means that this will take 10 seconds for each hopper to move their items to the next. When one of the hoppers is empty, for example if this were empty, this comparator would no longer be lit, meaning this redstone would no longer be lit to retract this piston. The redstone block would then move, which would then light the redstone for the following circuit. Now once items start coming back into this hopper, this piston isn't going to extend straight away. Once this hopper is completely empty, then this piston will retract, allowing this piston to extend. Which, as I explained just before, this will take 10 seconds each. So every 10 seconds, this redstone line will change from lit to unlit. Now we move on to the set of observers which actually requests the items to be put into the crafters. And if you compare this to what TangoTek has used, and that's because we need more generous timing. I'll be able to show you why later, but for now I'll just explain how this works. We have a row of repeaters all set to 4 ticks, which will extend across all of your factory. Observers are facing up, which will detect the repeater change, which will then activate the copper bulb. The comparator will then send the signal through to the observer, which will then trigger the stuff over that. Now depending on how big your factory is, you're going to need to adjust the timing of your hoppers, and the items that are inside it. The less items that are inside your hoppers, the quicker the timer is going to be. Because the timing is quite delicate with this machine, you need to make sure that these item requests are not overlapping each other. For example, you do not want this one being lit at the same time this one is. So it's generally a good thing to have more time than you need. Now we're getting into the binary encoder. The purpose of these observers is just to send a signal into this block, provided that is behind it, which will then be able to power these activator rails. If the redstone torches here are lit, then that means there's not enough items for it to craft another component, so the piston will extend, which will allow it to send the signal. Now I'm going to assume you know nothing about binaries, so I can explain this in a lot of detail. Binary is a computer language that is completely made up of zeros and ones, and each value is quite important. For this machine I've just got 4 digits. Every yellow concrete is a 0, and every observer is a 1. I've made some really ugly redstone just to quickly demonstrate how binary works. I know this is extremely bulky, but this is actually my first time making a display, so please don't judge me. These lamps signify the binary values, and there are 5 of these. At the moment it's all 0, 0, 0, 0, 0, meaning that our end result is, well, 0. But if the first digit were to be 1, we would get a value of 1. Now you see that the values of all these digits are 1, 2, 4, 8 and 16. They're pretty much doubling themselves. Well, these are the added values of the digits that make the final result. We could flip this to 1, but that makes 3. Well, that's because it's 2 and 1. We're adding these 2 digits together. So 0, 0, 0, 1, 1, the final 2 ones being 2 and 1, will add up to make 3. If I were to remove this 1, it gives you 2. If I were to do 8 and 2, or 0, 1, 0, 1, 0, you'd get 10. You might get the idea, but I had an extra 1, you get 11. That's the gist of binary. The same can be viewed here. 0, 0, 0, 1, we've got 1, and 0, 0, 1, 0 means we've got 2. Over here we've got 3, and then we've got 4, and so on. And this is great and all, but what does it mean? Well, these are just the values that I've allocated each material to. If I were to look into these hoppers here, I put redstone dust in this one, and sticks in this one. This one has nothing, because we're making redstone torches in this one. and it doesn't use a third ingredient. So remembering that it's redstone, then sticks, and nothing, we can see that there's different values for all of these, the block of nothing being nothing. Redstone is given the value of 1, and sticks are given the value of 2. You can see this same value being repeated here for repeaters, because redstone is also used in the recipe for repeaters. So we just need to send another signal allocated to redstone dust, which is 1. The signal is sent through all these activator rails, which are then led into the binary decoder. This is the main thing that's different from TangoTek's design, because I could not figure out how to get the design he used to work. So I did a lot of Googling on how to build my own binary decoder, and this is the end result I got. Now, I wasn't able to learn this myself. A lot of it was learned from Matt Batwings, which taught me the basics of how to use binary in Redstone, but it had a bit of a flaw, and that was that the longer that the decoder goes for, the more out of sync it gets. So I needed to find a design that works without breaking over long distances. And this is when I found a video by Proper English 19, which completely saved me the hassle of figuring this out myself. I've left a link to both of the videos that helped me out in the description. So we'll start with the basics. How is it working? Well, each of these lines are dedicated to one of these values. Because this is the 1 digit here, and this is the 2, we follow it all the way to the decoder. We see that this end line is the 1. Underneath we've got a row of redstone lines, and these are pretty much your 1, 2, 3, 4 and so on. These are the end results you're getting out of the decoder. You might notice that every 2 lines we get a redstone torch. And you skip a line, add a torch, skip a line, add a torch. And the same pretty much goes for this. You've got a torch, miss 2, add 2, miss 2, etc. The pattern will keep going for each digit, but it makes more sense to visualize it like this. Every time you see a redstone torch on these lines, it means the value is 0 in that line. We have a value of 0, 0, 0, 1, which means it's going to be 1. 0, 0, 1, 0 means we're going to get 2, and we're going to get 3 for this next one. Now how this works is the more magical part. Whenever a line does not have a redstone torch on it, you want that line to power the line beneath it. Because the 2 digit has intervals of 2 redstone torches and 2 gaps, we can easily just put a repeater in between 2 redstone lines and put it into a block which will power both of them for us. It saves us having to do a repeater setup like this. Now the reason this doesn't have the out of sync issue with long distance redstone is because of the way the repeaters are done. In the other design, repeaters were used everywhere, whereas this uses them quite sparingly. This redstone will power this block, which powers the repeater into this block, powering the redstone line. But the redstone travels above the repeater in a way that the repeater cannot mess with the signal. This allows the rest of the redstone signal to be transmitted instantly, without the delay of the repeaters to knock it out of sync. Whenever I do need to extend the signal strength, it's used in between redstone torches, because if it were placed on top of a torch, the block could no longer be powered, so this redstone torch wouldn't be unpowered anymore. I'm not the best at explaining this, so if you want a separate video on how to do binary encoders and decoders, then feel free to comment, and I'll gladly do it. It's something I'll be doing eventually anyways, but if I see enough about it, I may make it sooner. As I said earlier, each value here is representing a different ingredient. Just like we've got redstone dust, sticks, more redstone dust, redstone torches as 3, and stone as 4. 5 is just cobblestone and redstone dust for droppers. So if for example we wanted cobblestone, which was this value here, we would see that it's 0, 1, 0, 1. So we chase down this line here and see 0, 1, 0, 1. And these 2 lines will be active. It'll run down this circuit, which will then give us 5, which is cobblestone. And it's cool and all to tell you about this, but it might be easier to show you how it works. So I'll show on screen the order of the numbers that's going to come through. This all represents the binary that I've used here. I'm going to activate the machine and you'll see how the redstone lamps light up in order of what I've shown. I'm going to turn it on now. So as for the reason why this is delayed so much between each line, unlike what TangoTek used as just one line of repeaters, because TangoTek's decoder doesn't use redstone torches, his is a lot faster, whereas redstone torches take a couple of ticks to be able to turn off, and observers don't give a long enough signal strength to be able to invert redstone torches, so we need the extra signal duration from repeaters. Now we move on to the item requests. So when each line is activated, it'll activate this bit of redstone here. The repeater set to 2 ticks is just to be able to invert this redstone torch. The torch will be inverted long enough just to unlock this hopper to transfer one item into the dropper here. Once this dropper finds that there's an item inside it, it'll power itself to drop it. These chests are going to be where you store all your raw ingredients. In here I've stored redstone, sticks, stone, etc. This can probably be done in a much better way, so if you have suggestions, let me know. But for now this setup does a good enough job to work on its own. So when these items are all dispensed and fall into this water stream, it's brought up this bubble elevator, which will go all the way into this hopper. This is the main chest where all your ingredients are going to go into the crafters. Firstly, a redstone comparator is going to check the contents of the chest. If it has anything, it'll invert this redstone torch, which will allow this redstone clock to loop. Now if I were to remove this redstone torch, what's happening here is that this redstone repeater is powering this block, which unpowers the redstone torch. It's then constantly in a battle of unpowering and powering itself, until something else is powering it, which stops it. Every time this target block is powered, it'll activate this dropper, which is holding a bunch of minecart hoppers. If I put a few items in, a redstone torch was just made. The reason for the double chest facing this way across these two tracks is just so the hopper minecart has a bit more time to pick up the items. For this design in particular though, it's important that each time an ingredient is requested that it only drops one item. If a hopper minecart were to have too many items that it could place in the hoppers, then it's going to have it left over by the time it's destroyed. And unless you have a way for them to be recovered, it's going to get mixed up into this dropper, and you'll see why in a second. The hopper minecart will travel all the way up until it reaches here. This is just used to destroy the minecart and put it into a hopper. Because honey blocks are slightly smaller than regular blocks in all directions, the minecart is able to touch the fire, which will break it, but the hopper will be able to pick it up before it's burned. What you'd usually have is a dropper with a water stream to connect the lost minecarts all the way back into this hopper, which goes into the dropper again, but I didn't make it because I was simply lazy. You might think that why doesn't the items go into every single hopper? And wouldn't it need an item sorter instead? Well, that's the neat thing about crafters. It kind of is an item sorter. When a crafter is completely full, meaning all ingredients that are inside the crafter are at the max value, and all other tiles are locked, then nothing else can get inside. If we look into this hopper, we can see that there's 41 redstone dust, and a bunch of iron bars. These iron bars can be anything that's not in the current recipe of this crafter. Because iron bars aren't in this recipe at all, it's not going to find a place to go in. So when the minecart drives over this hopper, only redstone dust will be able to get into here, unless you have iron bars in this chest. The same rule applies for everything here. We've got a comparator linked to each hopper. These are checking whenever there's more than 45 items inside the hopper. If there's 45 items in the hopper, aka 4 iron bars, or whatever filler block you have, and 41 of your ingredients, then it's going to power 2 blocks worth of redstone dust, but not the third. This will allow this redstone torch to be lit, which will have the piston extend down. Each piston is linked to 2 slime blocks or honey blocks, which are connected to a block. The purpose of that block is just to allow the observer to connect his redstone signal to the activator rails. Once this does reach 46 items though, this redstone dust will be lit, which will unpower the redstone torch, lifting this block up, just like this one has, meaning it's got enough ingredients and does not need to request anymore. So when this observer tries to fire, it's going to be fired into nothing. But because redstone torches here only use 2 ingredients and do not have a need for a third, then I just removed this redstone torch. We don't need it. You could keep the redstone torch and add more iron bars in there to look like it's full, but I just prefer to just remove the torch completely. The obsidian used here is just to stop these slime and honey blocks from lifting it. We've got another hopper clock down here, and the purpose of this is just to loop around until these torches are lit again. If it weren't for these torches being lit, this redstone clock would constantly be going around. When it hits into this block, this redstone torch will be unpowered like it is now, but once it's powered again, it touches this block, which powers the crafter. The crafter will then spit out its redstone torch, which goes into the water stream, into the chest. I just want to pause real quick to explain something that I missed. When you're making your chests for your final components that have been crafted, you're probably going to want to put them into separate chests that are being tracked by a comparator. You can then set up your redstone in a certain way so that when your chest is full by a certain amount, a redstone signal could be powered that directs it into this block. What this does is that it constantly powers the block, which will stop it from getting unpowered and powered again. Pretty much it's locking the crafter, and that it'll never make more components until you have taken items out of the chest that's linked to your redstone line. Now what this pretty much means is that when a crafter has enough ingredients in excess, then These redstone torches are going to be unlit, which will allow the clock to keep going. If I were to demonstrate this now, I throw in 1 redstone dust. You see the redstone torches unlit, and the pistons retracted. Now we just need to throw 1 more stick in the hopper, and it should activate. Torches are unlit, the hopper clock is going, and now because they're lit, the clock will stop. But we've got an extra redstone torch in the chest now. So I've done a lot of talking, but let's show the machine in action. If I unpower this lever, the redstone block moves, which unpowers the redstone, which the observers detects the change, requesting items, which you can then see being this water stream here. Whenever items are detected in the chest, I hop a minecart, and those completed products are put into this chest. And because I haven't had a way to manually feed the dropper, I've got to refill it here. And we're slowly getting more components, so that's pretty much how the machine works. Again, it's quite different from TangoTek's original design. I couldn't understand how some of his components worked, so I decided to make it myself. It is a little slower, but it is functionally the same, so I hope this does a good enough job of explaining the gist of it. If there's anything else about this machine you want to explain more in detail, then feel free to let me know.